Hello students, this is Indrani ma'am from SIP Rasayan. In this lecture, I am going to explain products of CO bond cleavage in ethers using HI or HBr. Now see, ethers are the least reactive of the functional groups. The cleavage of the CO bond in ethers takes place under drastic condition using concentrated HI, hydroiodic acid, or concentrated HBr, hydrobromic acid, at high temperature. Now the order of reactivity of the hydrogen halide is HI is most reactive, then HBr, then HCl. Reactivity of HCl is least. This is because bond dissociation enthalpy of HI is less. So HI bond can easily be cleaved. Therefore, it is highly reactive and reactivity is decreasing in this direction. Now see, if you are having ether, suppose diethyl ether, if you are treating it with cold concentrated hydrochloric acid HCl, what you will get? You will get this oxonium ion. So since plus, that will be balanced by Cl minus. So after protonation, we will get this oxonium. How we are getting? H plus is there, lone pair of electrons will be donated and we will get this oxonium ion. But if you are using HI or HBr in limited amount, what will happen? This is ether, we are treating it with HI suppose. So what will happen? From here we will get ROH, means alcohol, and Ri. Ri means alkyl iodide. Now if you will use excess HI, what will happen? This ROH reacts further with HI and it will give another molecule of Ri plus water. So what is the overall reaction? Just add up. Left side ROR plus 2HI plus ROH, and right side 2 Ri molecules we are getting plus ROH plus water. Now left hand side and right hand side both are having ROH, so just cancel these two. So what is the overall reaction? Overall reaction is ROR plus 2HI is equal to 2Ri plus water. So if you are having excess HI or excess HBr, you will get 2 molecules of Ri plus water. But if you are having limited amount of HI or HBr, this reaction takes place. Now see, if both sides are not having same alkyl group, means ROR prime it is having, then what is the product? Here ROH R prime I or R prime OH Ri. To explain this, I will give some example. Now see, this is mixed ether. Why it is mixed ether? Because here and here two different alkyl groups are there. We are treating it with concentrated hydroiodic acid. So what are the products? Remember, when primary and secondary alkyl groups are present, lower alkyl group gives alkyl iodide. By which mechanism? By nucleophilic substitution by molecular SN2 mechanism. That means iodide attacks at the less hindered position. Now see here, this is alkyl group, this is also alkyl group. This is primary because this carbon is attached with only one carbon atom. This carbon is attached with also one carbon atom, so this is also primary. But this is less sterically crowded and this is more sterically crowded because here at adjacent position 2 methyl groups are attached with this carbon, but here no such alkyl groups are present here. So this is more open position, this is more crowded position. So what are the products? Lowered alkyl group gives alkyl iodide. We have seen already. So this will give alkyl iodide. So what is the mechanism? So here oxygen is having lone pair of electrons that will be donated to H plus, and here we will get this oxonium ion. Now see, this is smaller alkyl group. So here iodide will attack. You remember that thing. Another thing here, less steric crowding is there. Here more steric crowding. So what will happen? This bond will break and iodide will attack at this carbon by SN2 mechanism. Since this is primary carbon. So what are the products? From this side what you will get? CH3, CH, CH3, here CH2OH, and from this part you will get CH3, CH2I, iodethane. So these are the products. Next problem, what are the products for this ether? When we are treating it with concentrated hydroiodic acid. This is also mixed ether and this oxygen is labeled with O18. Here methyl group is there, here tertiary butyl group is there. So this carbon is primary and this carbon is attached with 3 more carbon atoms. So this is tertiary. When one of the alkyl group is a tertiary group, then we will get tertiary halide by SN1 mechanism. So first step, what will happen here? At the first step, if you treat this with HI, as we did in the last case, oxygen lone pair will be donated to H plus and we will get this oxonium ion. Then what will happen? This bond will break and we will get this labeled CH2OH methanol plus here we will get carbocation, because this is stable carbocation, tertiary butyl carbocation. So this is slow step. After that iodide is there in the reaction medium. So iodide will attack there and we will get CH3, CH3, tertiary butyl iodide. So one product is tertiary butyl iodide, another is labeled methanol. So what is happening here? From here we are getting these products by SN1 mechanism. So if one of the groups is tertiary alkyl group, then by SN1 mechanism you have to do like this way. Now see, in this ether, here oxygen is attached with one primary carbon and it is attached here with benzene ring. Since these two are in conjugation, means lone pair of electrons and pi bonds of benzene ring are in conjugation, so this bond, due to this type of resonance, having some double bond character, so it's very difficult to break this bond. But this lone pair of electrons are not in conjugation with this benzene ring due to this carbon atom. Okay. So what will happen at the first step? We will get this oxonium ion. Then see, with this oxygen, one primary carbon is attached, but this is benzylic carbon. So if we break this bond, we will get stable carbocation. This is stabilized by resonance with benzene ring. So here what will happen? We will get phenol plus benzylic cation. This is stable due to resonance. This is slow process because here stable carbocation we are getting. So reaction takes place by SN1 mechanism and now iodide will attack there and we will get benzyl iodide and phenol. These two products we will get here. Now this is next problem. This is also mixed ether. This is bicyclic compound. These and these two positions are called bridgehead position. So you have to remember, bridgehead carbocations are highly unstable. So at bridgehead position, SN1 reaction is very slow. And at this position, SN2 reaction is also not possible because it's difficult to get trigonal bipyramidal transition state at this position. So what's the reaction then? At the first step, oxygen lone pair will be donated to H plus and we will get oxonium ion. As I told you, this bond will not cleave because here at bridgehead position there is no SN1 or SN2. Or if the reaction takes place, it's very slow. So what will happen? By SN2 mechanism, iodide will attack here and we will get CH3CH2I plus this alcohol. Now last problem, which of the following is not cleaved by hydroiodic acid even at 525 Kelvin? Now see C6H5OCH3, all are ether. Okay. Now see here, this bond will not cleave because lone pair of oxygen is involved in resonance with benzene ring. So this bond is having some double bond character. So this bond will not cleave, but this bond will cleave, and here we will get products. Here also this is propyl group. So here this carbon oxygen bond will cleave. Here if limited amount of HI is used, this bond will cleave, and for this compound B, this lone pair of electron is involved in resonance. So this bond is having some double bond character. At the same time, this lone pair is involved in resonance with this benzene ring. So what will happen? It's difficult to cleave this bond also. This is not cleaved by HI. So this is your answer. Till this, if you like, please subscribe. Thank you for watching.